Hello and welcome back to another math video. Today I want to expand on last week's video about the online calculator Desmos. As I mentioned, this is a great graphing tool and a full functioning calculator. Another feature of the calculator is the ability to graph piecewise function. In this video I just want to show you how to graph them using Desmos. In a future video I will go more in depth about the topic of piecewise functions, but for this one I just want to quickly show you how we can actually use Desmos to graph piecewise functions. To quickly summarize what a piecewise function is, it's basically a function broken into parts. We use more than one formula to make up the function, and we put some restraints on parts of the graph. Hopefully seeing an example visually will make more sense. But like I said, I'm just going to show you in this video how to actually graph them using Desmos, and in a future video I can go in more depth what a piecewise function is and maybe do some more examples. All right, here's an example of what a piecewise function could look like. Depending on the function itself, it could look much different. This is just an example I used. It's like a graph, and it's broken into two parts. Now, in order to use Desmos to graph these, there's certain syntax that you have to use to put into the boxes to the left. First, you need to name the function. So I'll just use the example I already have. I'll just do another one. So let's name one, I'll call this one h of x equals, and then we use the curly brackets. The curly brackets are also found if you go to the hide keyboard or open the keyboard. They're these guys right here that I'm highlighting. So after you do the first bracket, you need to first set the domain of the problem. In this case, I will just say that the domain or restriction on the graph would be x is less than or equal to 1. Then I use a colon, and then I put in the actual function itself. I'm just going to make it another linear function. I'm just going to say 2x minus 2. And then to put the second part of that graph in, use a comma. You put the domain for the new one. I'm going to say x is greater than 2, colon, and then the graph itself, I'm going to say negative x plus 1. I'm just making these up. And then it already has the closed bracket. If it's not showing, then you have to put a closed bracket in there. And then here's my graph in blue. So the syntax is first define the function, name it. I could call this A2. I don't have to put f of a or anything like that, but just what a typical function looks like. It looks similar to that, so I put that in there. You use your curly brackets to start and close the function. You first put the domain in, then the actual graph itself, domain and graph. There can have been another one. I would do the same procedure. You put the domain, colon, and then the graph. So hopefully the syntax you have down. Let's go ahead and use an example from one of the quizzes that we can use Desmos to use to solve that problem. All right, here's the example problem I pulled from one of the quizzes. It says the function h of x is defined as shown. Here's my function. It looks like it's two linear equations, or linear functions, and here's my restrictions or my domains on parts of those graphs. And they want to know what the range is. Because hopefully remember what the range is. Range is your possible y values. So in terms of your coordinate plane, you're looking at possible values for up and down. So let's go ahead and see if we can use this information, throw it into our Desmos, and to see how easy it is to find the range of this piecewise function. Let me quickly delete these two. And all I'm going to do is type these into the box here, and we'll see what we get. So the first one, I'm going to call it h of x. That's what they're calling it. We can do the same thing. Equal to my curly bracket. First things first, we put our domain in. I'm going to do the first graph. This guy right here. Our domain, our restrictions are x is less than 3, colon, and then the actual linear equation or linear function, x plus 2. First one done, comma. Second one, the domain, x is greater than or equal to 3, colon, the graph itself, negative x plus 8, close the braces. So if I quickly zoom in on this, this is our graph. Let me zoom out. And they want to know the range. So if we look at our graph here, we're looking at just our y values, so up and down. So I'm looking at where my barrier would be, the way I look at it, where it starts in terms of my up and down. If I'm going all the way down, it hits here. And then it looks like if I continue down, it goes on for infinity. So this is telling me my range is everything that's 5, because that's our y value right here. We don't want the 3. The 3 is our x value. We want the range. The range is our y values, up and down. So this is telling me at 5, and then it goes on to infinity. So everything less than 5. And since this is filled in, that means we can include 5 as our answer. So going back to this, now if I was writing my answer for the range, my range would be h of x. And I said that it's everything that's less than or equal to 5. Remember, this is my border. I don't have anything higher than that. The highest number I can get for a y is a 5. And then I have everything underneath that. So I would say less than or equal to 5. So just looking at this graph itself, this piecewise function itself without looking at the graph, it's hard to identify the range. I just go ahead and punching that equation or that function into Desmos, hopefully you should be able to see it's much easier to represent your range by just looking at the graph. So we know it's 5 and it's everything underneath that. So if you come across a piecewise function, go ahead and bring up Desmos, plug them in using the syntax I told you, and hopefully the problem becomes much clearer or easier to solve. With that said, hopefully this helped, and have a great day.